I'm going to do some tests of this 1/3 horsepower 3-phase AC motor set up as a rotovertor. And so it's running on single phase AC. And I'm going to be running it from an inverter, which is just this little inverter, stat power inverter, that's taped to the top of this battery here. I'm not going to run it from the house power. And right now it's drawn, the battery is at 12.36 volts, and the inverter draws from the battery with no load on it 0.09 amps, okay? Now I'll go to step 2. Okay, this inverter, when you plug it in, it makes AC 120.4 volts, okay? Okay, now I'm running the rotoverter from this battery into the inverter. I have a 4 UF run cap across the L2 and L3 line, and I'm drawing 0.8 amps DC from the battery. Now I'm going to take off, I'm going to have it so there is no run cap at all. Now the draw goes way down to 0.47 amps. So let's try a 2 UF run cap. See what happens. Now this is, remember, this is not the house power. This is the inverter running it. There we go. So now it's a 2 UF run cap. I went down a little bit. Let's try a 1 UF. Okay, 1 UF run cap. Went down a little bit more. Here's a 0.5 UF run cap. .5 goes up. So let's keep a 1 UF run cap on it. And this is the draw. I'm going to just kind of grab the shaft and give it some little bit of friction. More friction. These are why these rotovertors are good for testing generators, for no lens breaking or minimal lens breaking. They're very sensitive. I'll put this push a little harder. Okay. Now, I want to try to get the draw down even lower by putting a run cap in parallel across the AC coming out of here. So just a minute, I'm going to see what I can do and come back. Okay, it doesn't do much good on when I was running from the grid power, running right from the grid. A parallel cap across the AC input would work as a power factor correcting cap, and you could really lower the draw, especially with my transformer, I remember. But anyways, so I'm trying to lower the draw by putting a cap across the AC input from the inverter right now, okay? So I'll show you. Here's a 0.1. We have, without the cap, it's 0.43. With the 0.1 cap across the AC input in parallel, it goes up to 0.45 on a meter. Now I should be checking what the scope says and see what this does with the phase shift, but right now I'm just going to do the meter. Keep it simple for a little while. Okay, hold on. Okay, whoops. Still going. So now I've shot it all the way up to 0.95 input with a 2 UF cap. And actually I've tried a bunch of caps, and I see it doesn't help lowering the draw with a AC cap in parallel when I run with the inverter, at least what the meters say. However, I did some experiments a few days ago, and I had a run cap in series to the L1 line. So the AC input has an AC cap in series, and I got some good results. Let me do that, and I'll show you what I mean. Okay, now I'm going to do something fairly interesting. I have a 0.5 UF cap. I have it in series from one of these AC lines from the inverter. So a series cap. I also have the run cap of 1 UF from the 2 to the 3. And I'm drawing the lowest I could get is 0.43 amps. And remember, this is DC, and I'm looking what comes out of the battery here. Now, going on here. Now I should have about 120 volts going into it, so I'm going to look at that. Yeah, there's 121 volts powering this right now from the inverter, and 0.43 amps. Okay, that is what's powering this. Now, watch this. What's interesting is I believe the voltage is going to drop down to 60 volts going into it. And I'm not using a transformer to knock the voltage down. I'm putting this cap in series to knock the voltage down. Let's see if it does it. I did this a few days ago. And not sure what is going to happen here, so let's try it. As soon as I unhook this, there it is. Cap is in series. Now look, I'm only drawing 150 milliamps. Yeah, and here's the voltage going in, 57.5. So isn't that interesting? I've knocked the voltage going into the rotoverter down to only 57 volts from 120. And I've also knocked down the amps going in quite a bit. However, I lost power, and I think I just knocked itself out of the sine wave latch. but I'm experimenting. So this is interesting how you can knock it down from 120 to 57. And I will, there, I'm starting it up again, you hear it? So I need to try some other cap sizes for this series cap. This is in series on one of the AC lines from the inverter going into the motor, actually the L1 line. Okay, so one moment again, I'm going to try to find something so it's not so extreme and it knocks itself out of sine wave latch. Hold on. Okay, now I'm going to run a 2UF cap. This one is in series now to the L1 line. So it's series 2UF cap, L1 line from the AC. Now look, the voltage going in is way up there, 189 volts. And the amps is way up too. So this really increases the power of it. The power draw, and I imagine the power of the motor as well, the shaft power. I'm trying to get this light to turn on. What's happening? Okay, so I'm drawing 111. See now there's 190 volts going in, not 120, because of this 2UF cap in parallel. So I'm drawing a lot more amps and a lot more voltage. I'm wondering what the shaft says. I'm going to put this on there. See, now it doesn't affect the draw so much, like when it's running on really minimal. I'm pushing pretty hard with this pen now, and it's not really making that much difference if the shaft is being loaded. Right now I'm pushing as hard as I can with this pen on the shaft, and it's being loaded, but look, see? It doesn't really affect it that much. And that's because I have a 2UF cap in series. Now let me find a 1UF cap. Hold on a minute. Okay, now I have that 1UF cap in series instead of that 2, and look how the draw goes way down. And so does the voltage. It's kind of like that 0.5 was, but now it's going so low it's latching itself out of the sine wave. Now I'll bypass this 1UF cap in series. Now we're back up to here of the input, and we're back up to 121 volts, okay? Now I'll quickly plug in the 1UF in series. And look how far that draw goes down. And it's only drawing 52 volts. So this is very similar to that half UF. I wonder what 1.5 UF will be. I'm going to try one more of these. One more experiment with this. What's interesting is how you can drop the voltage input by a capacitor in series from the inverter. So, hold on a minute. Okay, this is kind of successful. Now I have a 1.5, not a 2, not a 1, but a 1.5 UF cap in series. And now I've dropped the input down to 0.28. And the voltage has gone down to about 81. So instead of 52 and 0.19, I still have some decent amps going in, and decent voltage going in, and some decent amps. And remember, this is in DC. I'm measuring 12 volts, so this is 12 volts times 280 milliamps going into this thing. It's going 1800 RPM. It goes the same speed, give or take a little bit, because that's the way it works. It runs on AC. So, and it's not stalling. It didn't go out of its sine wave latch. So, this is good. Now I could be checking the run cap phase, how much is still across the run cap in voltage. Let's look at that right now. Okay, something interesting. It's 0.28, 81 volts input. And if I just take off the run cap of 1 UF, not the series cap, but the run cap between L2 and L3, if I just take that off so there's no run cap at all, the volts drops down to 74, and the amps input drops down that much to 25, so this is something interesting. But I'm going to plug that back in because it seems like we should have a run cap hooked up. So back again to where we were, 81 volts input, and 20.28 amps input. This is AC I'm looking at from the inverter output. And remember, we're running on a battery, 12 volts, so the draw is 0.28 times 12. Okay, what was I going to do? I was going to look at the run cap. I wonder what the voltage is in the run cap. Just a minute. Okay, I'm checking right across that run cap of 1 UF. 59 volts. Did you see that before it fell? 59 volts. Okay, one moment. Okay, here it is again. The run cap. 1 UF run cap between 2 and 3. Between 2 and 3 lines. Typical rotovertor run cap thing. 58 volts, almost 59, 59 volts across it. Now, what is it if I don't have this series cap? What is it then? So let me do that. .96 volts across it without that series run cap hooked up, the 1 UF. Just something interesting. I don't know. I could keep going, hook a scope up with it, Let's look at what the current is. Now when I do a step down, if I take the run cap and I step it down with a transformer, I pump it back into the inverter, you know, doing the loop. But right now, what was most interesting is how you can adjust your voltage input by a series run cap from the AC coming out of an inverter. And now you see tuning a rotoverter, how much fun it is. It's kind of fun. And thanks for watching.